Okay, so today we're gonna redo actually this example, even though I did this one in class, but thanks to some of you that point out my mistake with the partial decomposition. So I apologize for that, and I want to redeem my sins. Okay, so let's begin. Right, and I will show you where I make a mistake in class. Okay, so let's begin with Laplace, right? Laplace both sides, so Laplace y double prime, Laplace y, and Laplace of the sine of 2t. Okay, term by term, s square y sub s minus s y sub 0 minus y prime of 0. Right hand side, actually not yet, my bad, y sub s for this term. Okay, right hand side, recall Laplace of sine of at is just a over s squared plus a squared. Okay, so therefore Laplace of 2t it is s squared plus 2 squared, which is 4 and 2 in the numerator. Okay, so far good. Next, we're going to plug in the initial condition, which is y is 0 equal to 2 and y prime 0 equal 1. Okay, that will give me 2 here and 1 here. Okay, and at the same time, I'm going to solve for y sub s. Okay, that means I'm going to group them. Okay, so group them like this. Group them use the coefficients s squared plus 1, and then plug in the initial condition. I have 2 minus 2s minus 1 equal to right hand side. Okay, I know that I'm gonna solve for y sub s, right? So I'm gonna move term by term to the right hand side. Plus 2s plus 1. Okay. Next, solving for y sub s, meaning I have to divide both sides by this s squared plus 1. Divide by s squared plus 1. Okay. How about, okay, I rewrite like this. Okay, for the first one, a over b but divided by c is just a over b times c. Right? So it just turn out to be s squared plus 4 times x squared plus 1. Okay, plus 2s over s squared plus 1 plus 1 over s squared plus 1. Okay, so right here, so far so good, right? And also I know that this one, it turned out to be 3 fractions, and eventually I will need to reverse engineer, find the inverse Laplace to find the solution, right? Lower y sub t, right? Then the goal is looking for each one of them and find any formula on the table on the handout that is bear resemblance to them. Okay, and it's turned out we're looking at one of them right now, right here, that one right there. Okay, so I'm gonna copy them, maybe copy that, bring it down. I'm gonna put it here. That is one of that. Which one that look familiar to this? Well, similar to this. There. Okay. How about the middle one? The middle one, yes, you guessed correctly, which is Laplace of cosine of at. Right. It turned out to be s squared plus a squared. Same denominator with the sine, but the numerator is just s. Okay. Then I also have s right now in the numerator, as there s here. How about that number 2? So instead of write that number 2 there, how about I put the number 2 in the front? So now I have reverse engine. If I reverse engine, I have at least 2 of them, right? So one by one, let's write them down. So if I inverse Laplace, it's not equal, huh? Don't write equal like this, they're not equal. So reverse, right? Reverse engine, inverse Laplace, just 2 cosine of A in this case is 1, right? 1 square here, 1 square here. So 1t, just t. One more time. Inverse Laplace is sine of t. 1t, right? Is t. So I have 2 of them. And the third one, which is the first one, technically the first one, is something we don't know. Okay, but that their combination will be your solution to this problem, right? The solution to this problem. So let's look for them. Look for the first one. So I'm gonna play around with this one. Okay, I know that in order to find the inverse Laplace, I have to split them out. To break it down into small chunks where I can find the formula in the handout. Let's break it down in small chunks, and that process of breaking it down is called partial decomposition. And this is where I make a mistake in the class. I sincerely apologize for this. It's not actually a true mistake that gives you the wrong answer. Nope, it still gives you the right answer, but it's just unnecessarily long. Okay, and which is I'm very embarrassed of. Okay, in the class I gave you, I remember it should be AS plus B or CS plus D, right? I gave you something like that. Okay, and then you cross multiply, right? I cross multiply, which is very unnecessary. This is first of all, fully FYI, is completely correct, but too long. Okay, unnecessary. Why is that? Because if you look at the right hand side, that is a constant. So if I cross multiply, I have AS plus B times S squared plus 1, right, plus CS plus D times S squared plus 4, right? This is correct, still correct. I have ASQ plus AS plus BS squared plus BS plus CS Q plus 4CS plus DS squared plus 4D. Because on the right hand side and the left hand side just a constant. Therefore, every term with the SQ, these coefficient right here, most of them it's just 0. Most of them is just 0. Let them equal 0, and you have to have a system of a system of 4 equation A, B, C, D, right? To solve for A, B, C, D, 4 variable, 4 equation, unnecessarily long. Okay, so therefore, instead of let the numerator to be a first degree, AS plus B, while on the left hand side it's just a constant, then instead of doing that, I just let them A and B. That would be more than enough already. Okay, and then you're gonna have your math much easier now. Okay, so let's cross multiply them, shall we? Okay, so cross multiply, left hand side is number 2, right hand side AS squared plus 1, B S squared plus 4. Okay, distribute, and then I'm gonna combine. Okay, I'm gonna bring the this like term together. Okay, plus A plus 4b. Okay, so that is 2 a plus b inside the s square outside plus a plus 4b. Okay. So if we don't have this, if we don't choose a and b because of the left hand side coefficient, then a and b are left hand side is constant, a and b are constant. If we don't do this, we use as plus bs and cs plus d, we're gonna end up with the third degree, and then we let a bunch of them equal 0 anyway, right? Okay, so term by term, this basically look like this. All right. So technically, actually, that's better. 0s squared there. If I compare them, I will have a plus b equals 0 for the a plus b coefficient, and actually drop the parentheses. And a plus 4b is 2, the constant term. Did this give me a is negative b or b is negative a? B equal negative a. Then a plus 4b, that means 4 times negative a equal 2. That means a minus 4a, right? A minus 4a equal 2. A minus 4a is just minus 3a equal 2. Then a is just negative 2 over 3. Because a is negative 2 over 3, b is opposite with a, so b will be 2 over 3. Okay. Keep going. We have 2 over s squared plus 4 s squared plus 1 equal negative 2 over 3 for a. Okay, actually let's write in numerator. Okay, 2 over 3 s squared plus 1. There you go. Okay, it should originally look like that, but we don't want these two numerator here, right? Because they are fraction, right? They look a little bit off. Okay, how about I put that 1 over 3 to the numerator, 1 over 3 to the numerator. So negative 1 over 3 x squared plus 4. I still have number 2 plus 1 over 3 x squared plus 1. Why didn't I write like this? Okay, why did I intentionally leave number 2 inside and just bring 1 over 3, negative 1 over 3 outside? Because I look at the denominator, I know that I need to reverse engine one more time, right? To find the solution. I have to do inverse Laplace. I see that 4, that turned out to be just 2 square. And to match the formula, either side, cosine, I need 2 over here, right? Okay, and the second one, I see 1 here, that is just 1 square. Then to match the formula, I need 1 over here, and then 2 has to be outside. Okay, you see how they match each other, and both of these we have, when you do the inverse Laplace, they are just a same formula, which is Laplace of psi at, which is a over s squared plus a squared. Okay, so now I'm gonna inverse Laplace both of them. Which is negative 1 over 3 psi of 2t plus 2 over 3 psi of t. Okay, so the first fraction number 1, give me that. Okay. The second fraction we did earlier, and the third fraction give me this and this. So that question mark is down there. So in other words, we finished, right? The final solution, y sub t, now instead of writing this question mark, I have the box down there, plus 2 cosine of t plus sine of t. So the solution, it is y sub t, the particular solution to be exactly, right? The question mark, negative sine of 2t, plus 2 over 3 sine of t, plus cosine 2 cosine of t, plus is it a plus? Yeah, plus sine t. Okay. And by the look of this, I see this sine t, this sine t, they're the same term. How about I combine them? Okay. So I combine them. Negative 1 over 3 sine. Actually, I'm going to reorder them. Okay, reorder 2. 5 over 3 sine t. Okay, these two. Give me that. The cosine after that, and then the minus 1 over 3 sine of 2t. Okay, this is a solution. The reason I reorder them to be like this, so that I can show you that. If you solve for that problems, okay, using the undetermined coefficient technique, right? Undetermined coefficient technique. We start with solving for the particular solution, which is y r squared plus 1 equals 0, equal plus or minus 1, and then the general solution, the complementary solution, is a sine t plus b cosine t, right? And then you take the first derivative, second derivative, right? And then you plug in, then find a and b. Then you have your general solution. That would be these two. Right? See that? How about this last time? That negative 1 over 3 sine of t. Then go back to this one. What is the next step after you find the complementary solution? This is g of t, right? That's g of t. Then you're gonna find a particular solution by guess, right? Or assume particular solution has something that's similar to sine of 2t. It turned out to be a sine 2t plus b sine 2t. I mean b cosine 2t. Particular solution is like that. And then you take first derivative, second derivative again. Then you plug in, blah 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 blah. Eventually you're gonna see that your particular solution will be negative 1 over 3 sine of 2t, which is here. Okay, so that is the beauty of Laplace. Okay, Laplace, you transform the second order into something purely algebra. You don't have to do during solving for the process. You just flip them back and forth between Laplace and inverse Laplace, and then you get your solution without doing derivative and integral anywhere. Okay, so catch you in the next example.